Welcome to Mathematics Videos. This is the Calculus Unit 8. We'll be studying area and volume in this unit, but for today, we're going to concentrate on area. We're going to start off by doing a review. This is a piecewise function. It says f of x, which we know f of x is another name for y, is equal to x for values that are greater than 0. So, all right, had to make a small change here. So I want my y to equal x, and this is a slope of 1. So here to here, as you can see, going up the line from 0 to 5. And also, I want to know the area of y equals 4 between 5 and 10. So here's the graph of our piecewise function. We know if we're doing area, we're going to have to integrate. So we would definitely integrate our function right here. So our integration here will be from 0 to 5 of x. We're integrating with respect to the x-axis. Our other function would be from 5 to 10 of 4 dx. And that's the proper way, the calculus way to do it. But we know how to reason, and we could reason this off and say, hey, this is a triangle. We know the area of a triangle is 1/2 base times height. And we know that the base is 5, the height is 4. That's 20, and half of that is 10 units squared. Okay? If we take this out, let's switch colors, and we go from 5 over here to 10. This shape is a rectangle, and it is a 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 by 4, which is 20 units squared. So the total area here is going to be, total area is 30 square units. We could integrate that, but we would definitely get the same thing. So this is what we've been working with. We've been doing area, but basically we've been doing area that is bound between the x-axis and whatever the function is. And sometimes the function could be a line, sometimes it could be a constant, or sometimes it could be even trig. But what we're moving into in this next unit, we're going to concentrate on areas that are bound between two functions and not necessarily the x-axis. So here we go. All right, so let's get it started. We're going to find the area enclosed by these two graphs, y equals x and y equals x squared. So before you write anything, let's just get an idea of what these look like. Well, let's see, light sketch, y equals x, looks like this, goes to the origin. And y equals x squared is a parabola, and so my parabola looks something like this. Now the question says, find the area that is what? Enclosed between the two. Which area would be enclosed between the two? Well, it definitely would be this right here, the mild smiley face. Oops, what happened there? Slide it down. All right, so how in the world are we going to find the area enclosed when they didn't give us any additional information? So let's see what we can do. All right, here's a TI-83 graphing calculator picture of these functions. They're not bound by the x-axis, they're bound by each other. So to find the area between two curves, there are a few things that we're going to have to do. All right, so we're going to switch over here to the notes. Find the area between the two curves, and then once we get this information down, we're going to take it and go back to that problem and try to apply it. So I have my A right here for area. Area we're going to integrate. We got the colors going on here. I got my integration symbol. And I have limits of integration, which are A and B. Then I'd like for you to look and see that this A and this B are in blue, and so is this dx. I need to make mention of that because when we talk about integrating a function with respect to x, then our bounds, lower bound and upper bounds, must be in terms of x. In other words, you're looking at this clearly from the x-axis. So when we're doing that, folks, we are going to say, hey, if I'm looking at it from the x-axis, which of the functions is on the top? And we're going to take that top function, whatever it is, and we're going to subtract it from the bottom function. We're going to simplify this information, and once we simplify the information, we will go on to integrate. But we need some more information. Here we go. All right. The question is, we're fine with finding the top function and the bottom function. We're fine with saying, hey, I can look at this and say, looking at it from the x-axis, so I'm definitely going to integrate with respect to x and use my dx. The question is, how do we find our limits of integration? How do we find the a and how do we find the b? Here we go. In order to find a and b, you're going to set f of x equal to g of x. This is always how you find points of intersection. You set these functions equal to each other, and once they're equal, that means they're at the same place. So how do you find your limits of integration? You set a is equal to b. All right, so we're going to go to the next page, and we're going to write down some general steps, and then you're going to be able to refer to those steps as we go through the examples. Stay tuned. All right, step one. Step one, you're going to have to determine if you want to use dx or dy. And I'm going to go into when you would use dx and when you would use dy for your notes, and then we will move it right along. Okay, so here we go. You have a function like this. You can clearly see that you're going to use the x-axis, so this will be a dx. You'll have the top function and the bottom function. When I say dx, we have small changes here on the x-axis. In other words, if you slice this into individual rectangles, you will be slicing them according to the x-axis. So if you see that your slicing needs to take place against the x-axis, you will be integrating with respect to x, so make sure you have a dx. If you're given or you decide to do a dy, then you will be slicing your rectangles against or according to the small changes on the y-axis. So your rectangles will slice dy's, which is against perpendicular to the y-axis. So this is when you would use dy to integrate. And if you decided to use dy, dy is going to be your left function minus the integration of your right function. So I want to take a look at this. When you look at this, this right here is going to be, oops, hold tight, hold tight. All right, let's correct that error. If you're going to integrate with respect to the y-axis, it's going to be right minus your left function. Okay? So dy dx all determined. You have to determine if you want to use dx or dy, and it all depends on if you can slice it nice against the y, go with the y, or if you can slice it nice against the x, go with the x. It all depends on the problem that I'm giving for the work. If they already have it set up, I'm going with which one is more efficient. All righty, let's see what's next. All right, step two, that's the one we talked about it already, is when you let f of x equals g of x, and this is when you find your points of intersection or your limits, your a and your b, your upper and lower limits for the function. Step three, you're going to determine, step three, am I doing a right, left? Am I doing a top, bottom? Why is this important? Because you have to set up your integral. You're going to set up the integral, okay? So your integral may be set up like this. Integrate top minus bottom. Or you may have to integrate and say right minus left. So it's very important in the third step. Right, left, top, bottom, where are we going? So you want to set up your integral. The last thing you want to do, is what? What do you think it is? You guessed it. The last thing is we integrate. So these are the steps. And I think that was what? Step 4? So let's put it to you. All right, so y equals x and y equals x squared. I think I'm going to integrate this with respect to x. So I believe I'm going to go with a dx. I need points of intersection, so I want to set these two equal to each other. So I say x is equal to x squared. I subtract x on both sides, and I get x squared minus x equals 0. When I solve this, I pull out an x, and I get x minus 1 equals 0. So my integration points are x equals 0 and x equals 1. So guess what? I have my limits of integration. I'm going to start at 0 and go to 1. So looking up here on the graph, this is x equals 0. And this right here is going to be where x is equal to 1. So I'm moving right along through my steps. I know I'm going with a dx. I have my points of intersection, which are my lower and upper limits. That's going to be x, so that's going to be top minus bottom. I asked myself, what in the world is this function right here that's on the top? Is that the line or is that the parabola? Oh, great. That is the line. So here we go. I have my top minus my bottom here. This is supposed to be x squared. And then I have dx. And so all I do is I integrate that and substitute in for the fundamental theorem of calculus. And let's see what we get. Okay, so we have 1/2 minus 1/3 minus 0. All right, so this is 1/6 units squared. All right, so this is dx. We'll put together another video. We're going to do the same problem, and we're going to integrate this with respect to y. Let me give you one problem that you could try on your own, and then I will go into the next video with the answer to that. Hold tight. Okay, do this one on your own. I need the area between these two curves. We call them curves, but sometimes they're curves and lines, but we call it curves. Find the area between these two functions. Show your work. Stay tuned.